Hello, everyone, and thank you for joining us. Me and Luca will cover the paper on the four perspectives on computational creativity in theory and in practice. We know that this topic was touched on last week in the second presentation, so we will just take the discussion into a bit more detail now. This paper was published by Jordanous in 2016 in Connection Science, and it's not a theory of creativity per se, more like common elements that frequently surface in creativity research. It's sort of a meta perspective that can guide us and use us, and it has some evaluative elements to it. So it's important for us and useful to us for evaluating whether a system is creative or not. As the title suggests, we'll break up the work into the theory and practice. I'll cover the theory in section 2, and Luca will cover the practice in sections 3 and 4, and we'll end with a brief discussion and critique as well as a few discussion questions. So, what is creativity? Creativity is a very important idea, and many theories have been proposed over the last 100 years or so, especially around the end of the Second World War when psychometric testing was being developed and people like Robert Sternberg proposed the early theories of intelligence, like the triarchic theory of intelligence, the general factor theory, crystallized versus fluid intelligence, and so on and so forth. One of the most well-known theories of creativity is the one proposed by Csikszentmihalyi in 1990, describing a state of flow, which happens when you have the ability to do a challenging task well and you kind of get into the zone, lose track of time, and so on. According to him, flow is the mental state in which a person performing an activity is fully immersed in the feeling of energized focus, full involvement, and enjoyment in the process of creativity. It has been said that creativity is intelligence having fun, so creativity is closely associated with intelligence. It reminds me of Howard Gardner's book in 1983 called Frames of Mind. He proposed that there are multiple intelligences, like, for example, interpersonal, linguistic, mathematical, visual, and so on and so forth. And I think this is quite relevant to our discussion. So, given all these ideas, what makes a good theory of creativity and how can we use it in designing creative systems? That brings us to the topic at hand. The theory that we're currently focusing on is the 4Ps, or the 4Ps perspectives, or four perspectives, being the person, process, product, and environment. It was initially proposed by Rhodes in 1961 and developed and extended by others. Mooney in 1963 argued that the four approaches should be integrated in a model of creativity, proposing a model that puts together the four approaches by showing them to be aspects of one unifying idea. Tardif and Sternberg did a review in 1988 showing that in creativity research studies, that different authors highlighted a variety of characteristics with no general consensus and no characteristics common to all reports. So this is essentially the idea here, is that the 4Ps are common to all approaches and all studies, and it can be used and should be used in computational creativity research. So Alan Turing asked the question, can machines think? And we know that yes, they can think. So now we propose to consider the question, can machines be creative? And the answer is yes. Obviously, machines can be creative. We can see that in ChatGPT. But why? Why are they creative? How do we know they're creative? What aspects do we consider to be creative? Are we interested in the output features of the process? So traditional studies have focused mainly on the output and process, and we will now extend this idea by including the person and environment. Quickly, a definition of computational creativity: it is the modeling, simulating, or replicating of creativity computationally. So in examining and learning from these creative systems, from what perspective should the creativity of a system be considered? The International Conference on Computational Creativity invited papers addressing the process versus product. dimension addressing the issue of evaluating and estimating creativity or the progress towards it in computational systems through study of what they produce, what they do, and combinations thereof. This paper argues that to consider process and product is not enough. Computational creativity should be considered and explored from four different perspectives known as the four Ps: the creative person, product, process, and press or environment. So the four Ps perspective was initially proposed by Rhodes in 1961, who identified um, these perspectives by collecting 40 definitions of creativity and 16 definitions of imagination. Several people have independently identified these ideas supporting its credibility. Plucker and colleagues in 2004 derived a definition of creativity by identifying recurring themes in creativity research. Creativity is the interaction among aptitude, process, and environment by which an individual or group produces a perceptible product that is both novel and useful as defined within a social context. Kaufman has extended the idea by describing addendums or additional Ps, that being persuasion and potential. The person or producer is the individual agent, group, or machine that is being creative. It is proposed in this paper that the term producer is more appropriate as it allows us to consider the four Ps in the context of both human and computational creativity, in other words, machine creativity. This would refer to characteristics associated with individual groups of people, such as personality traits, attitudes, intelligence, temperament, habits, and behaviors. In the case of a machine, this might refer to the operating system, programming language used, or configuration of files. Tardif and Sternberg suggested three modes of studying this element of creativity, being cognitive psychology, psychometric testing, and human development. The producer is analogous to the computer system, program, software, robot, or agent within a multi-agent system. Colton's creative tripod has extended this a bit, claiming that for a system to be considered creative, it needs to demonstrate skill, imagination, and appreciation. We come now to the process element, which I think is probably what we would be most interested in as AI programmers designing creative systems. We would want to know exactly how creativity is implemented in the brain so as to have biologically feasible or biologically realistic systems. The process refers to what the creative individual does to be creative. A process might be sequential or cyclic stages. It might also not be sequential. It could be something like composition by improvisation being something unique to humans. Creativity doesn't happen at a single point but develops over time. We also consider processes where more than one agent participates. A process could refer to something like software, such as an algorithm. It could be a machine-machine process, a machine-human process, or a process between the machine and the environment. Some research has been done on process elements of creativity, such as the Flow R framework, which facilitates computational workflows by chaining together processes in a linear pattern. Some algorithm examples might include genetic programming, generate and test, engagement reflection, generating artifacts, and amending. The face and idea models are also mentioned here. I think this was covered in last week's presentation, so I'm not going to go into much detail there. The product is what we ultimately care about. It is a tangible, discernible, perceptible outcome of the creative process. Many authors advocate that proof of creativity is necessary to be considered creative. According to Kagan, creativity refers to a product, and if made by a man or woman, we give him or her the honor of the adjective. The success of systems is often reported in terms of what kind of artifacts they create, and some systems have been evaluated using Graham Ritchie's empirical criteria. This would be one of my criticisms of the paper. They might as well just mention these empirical criteria, because otherwise, what's the point? And finally, the press dimension refers to the social context in which the product is received. It is a bidirectional idea referring to both the environment which influences the creator and the one in which the work is received. Creativity doesn't exist in a vacuum. This is an aspect that is frequently neglected in creativity research. And some authors have proposed frameworks that consider the social aspect of it, such as Sosa and Gero in 2015, who proposed a multidimensional creativity framework consisting of cultural, epistemological, and societal levels. That concludes my section. Thank you for listening. I'm now going to hand over to Luca to take us through the second half, and I'll see you again at the end for a quick critique and discussion.
This section of paper delves into the ongoing debate within computational creativity regarding whether the evaluation of creative systems should focus solely on the output they produce or also consider the process embedded with the systems, called the product process debate. The discussion is centered around two main aspects, one advocating for a black box approach, primarily assessing the final product, and the other arguing for the inclusion of process evaluation alongside product evaluation. Okay, first, Ritchie argues that assessing creativity should concentrate solely on the product of systems, neglecting the importance of process evaluation. And here, Ritchie's perspective highlights the challenge of observing the underlying creative process within both humans and artificial systems. Then Hofstetter and Pearson-Wiggins emphasize the significance of understanding the creative process in evaluating creativity, because process understanding allows for a deeper insight into the mechanisms behind creative output, influencing the evaluation criteria. And without understanding the process, the evaluation of creativity may be superficial or incomplete. Then, therefore, Colton presents examples from art to argue that the process is as important as the end product in assessing creativity, particularly in the artistic domain. Therefore, Colton cites conceptual art as evidence, and Soloveit's definition of conceptual art emphasizes that the idea or concept behind the artwork is most important. Therefore, Jordanous supports this view in the context of musical improvisation, where the process of improvisation is often considered more relevant for creativity than the end result itself. And if assessing how creative a piece of conceptual art or musical improvisation is solely by evaluating the product, then there are two negative consequences. The first one is that a key aspect of intentions of the artist or musician is overlooked, so that the evaluator's focus is on the end result rather than how the creative work is made. And secondly, the level of creativity presented could be misjudged, especially if the creative process results in producing something that might seem commonplace outside of the context of that art installation or musical performance. And to prove that point, Galton introduced a thought experiment considering two nearly identical paintings presented at an art exhibition, and on both of those two paintings are dots placed, where the first one presents just randomly placed dots, while the second one presents the dots placed to represent the artist's friendships. Colton then argues that the second one would be more appealing and therefore demonstrates how knowledge of the creative process influences the evaluation of creativity. It seems that disclosure of the creative process can impact the perception of creativity. And still, critics could question if the experiment explores perception of creativity or if it rather explores the quality, which is in this case the appeal. So, and then when evaluating computational creativity, evaluation methodologies mostly just looked at systems output only or at the combination of output and process. The press, or called environment, and producer haven't been taken into consideration. And in 2016, Colton and Jordanous introduced frameworks such as the creative tripod and specs, advocating for a balanced consideration in evaluating creativity. These aim to provide a comprehensive evaluation framework for a creative system. The creative tripod, introduced by Colton, Introduces the press as a part of evaluation in the meaning of how an audience perceives the creativity of the system, while specs, introduced by Jordanous, requires the researcher to investigate what creativity means in the context of their system and to consider the interactions between audience and system. Showed here is a graph just to give an impression of the distribution of the 4Ps in the key international conference in this area called ICC in the year of 2015. We will not go in detail since it's already 9 years ago. However, back then all 4Ps were mentioned in the papers presented fairly evenly. 55% of papers considered the producer in computational creativity by some angle. For example, characteristics, what a system should implement in order to be creative, while 63% gave details on the creative process being used in the work being presented, as well as 63% focused on some attention on the creative products being computationally generated. Lastly, 66% of the papers mentioned how computational systems were influenced by external environments to some degree. And even though all 4Ps were considered to some extent in the papers, the figure clearly illustrates that they were not at a level where all 4Ps, where like papers consider all 4Ps at one time. And then when it comes to how to apply the 4Ps, there are two key parts of creativity. First, novelty, and second, value. Novelty, meaning originality or newness, and value, meaning usefulness or appropriateness. We can discuss both novelty and value from the perspective of all 4Ps. Starting with novelty. From the product perspective, we consider the evaluation of how novel a system's output and products are by evaluating a creative system itself. While for the process, exploring of novel approaches, algorithms, and techniques in the creative process are crucial. And from the producer perspective, it can be considered novel to run a creative system on a new hardware or in new software implementations, because it may impact the system's performance and then lead to unexpected results. Lastly, a system can be noted as novel in a particular environment, even though it may be commonplace in others. Coming to value. Taking a look at value and the meaning of the 4Ps, starting with product, it is associated with a system's output and products being valuable or good. In the meaning of process, a valuable process can be used for learning and studying for cross applications to new areas, as an example. To consider a producer, some get more recognition in their field due to being cited more, contributing in their field of study based on personal characteristics, experience, and influence. And lastly, a creative system holds value to the press if creative activities benefit the external world in some way. And then to give an overview and in conclusion, is that it's important to say that the treatments on novelty and value provided above are not exhaustive but rather brief. They serve to illustrate the diverse viewpoints that can be uncovered using the 4Ps framework, and considering those perhaps overlooked aspects provides a closer rendition of creativity in computational research. And we should acknowledge that while not all good papers cover all 4Ps, breadth of discussions across the 4Ps can potentially make the content of a paper more relevant across diverse audiences.
Okay, so that concludes our discussion of the 4Ps framework of computational creativity. I don't want to go into too much critique, since the reason we chose this paper was just to add a bit of context to the discussion before we move on to the machine intelligence and NLP applications. I do have a couple of problems with the paper. It's useful, it does what it's supposed to, but it doesn't give enough detail. For example, it mentioned that creative systems have been evaluated in terms of Graham Ritchie's empirical criteria without actually giving the criteria, so I don't really see the point of that. But in summary, The 4Ps framework is a useful heuristic for evaluating the creativity of machines, and the author did extend the discussion from um, creativity to computational creativity and mentioned some specific machine applications. So I'd like to open the discussion with Howard Gardner's theory of multiple intelligences. So basically, Gardner said that there's more than one kind of intelligence. Instead of the strictly linguistic and mathematical abilities measured by IQ tests, there's a lot more to it. For example, kinesthetic intelligence, as in athletes, musical intelligences. They added naturalistic intelligence to this, which is like if you think about Charles Darwin, for example, um, being a good scientist, being able to come up with novel ideas, predictions, and hypotheses. I think later they also added existential intelligence to this, grasping the meaning of life and whatnot, as in um, philosophers. So, do you think that machines can be creative in all of these domains? I mean, if you think about ChatGPT, it is a large language model. A large language model. It is linguistic in nature, but will these abilities in machines eventually be extended to kinesthetic and social intelligences? Can a machine be socially intelligent? That concludes my question. And as for Luca's question, how do you foresee the integration of the 4Ps framework influencing the future perception and acceptance of AI generated creative works? So, thank you very much, everyone. Also, much thanks to my team member Luca for her assistance with the presentation, and that will conclude our business for today.